I'm Joe Kirshner with American Water College. Watch as I use my 5-step approach to solve this problem.
Another type of chemical dose problem you'll want to know how to do is how to chlorinate a well. So here we have a well with some volume of water in it. So there's going to be some water depth in this well casing, and it's going to have a diameter. So one of the formulas you're going to need to calculate the volume of water in this well is volume equals 0.785 times diameter times depth times 7.48 gallons per cubic foot. So let's look at one of these problems, and it reads, a newly installed well must be disinfected with a dose of 100 milligrams per liter. The well is 750 feet deep. Water level is 115 feet below ground surface. The well casing is 14 inches in diameter. How many pounds of 65% HTH must be added to the well? So we're dosing at 100 milligrams per liter. And basically I'm just going to pull all this information out and put it in my known and unknown categories for step 1. So we need to know how many pounds of 65% HTH to give us a dose of 100 milligrams per liter. The well depth, so all the way down to the bottom of the well, is 750 feet. The water surface is 115 feet below the surface, which means the difference between 750 and 115 is the actual water level in the well. And the diameter is 14 inches, so I converted that 14-inch diameter to feet by dividing 14 by 12, and that gives me 1.167 feet for my diameter. So like I said just a moment ago, the water depth, or the column of water in this well, will be the depth of the well casing, 750 feet, minus the surface of the water, which is 115 feet below grade. So 750 minus 115 feet is 635 feet. So that 635 feet is that's the depth of the water, the column of water. It's 635 feet deep, and this diameter is 1.167 feet. We can use that now to calculate the volume of water in this well. So to calculate the pounds of our chlorine, we use this formula that reads pounds equals volume in million gallons times your dose in milligrams per liter times 8.34 divided by the percent concentration, which in this case is 65%. But notice it's entered as a decimal. Okay, so we're going to enter that 65% as 0.65. So we need to get our values to plug into here. So we need to calculate this volume using our diameter and the depth using our volume formula. So 0.785 times our diameter of 1.167 times our diameter of 1.167 times our depth of water, 635, times 7.48 gallons per cubic foot gives us a volume of 5,078 gallons. Now notice our volume has to be in million gallons. So I'm going to take this 5,078 gallons and convert it to million gallons. So basically I'm going to divide it by 1,000,000 and add a capital M to it. So here's how that looks. I take my 5,078 gallons and I use the equivalent of a capital M for million is equivalent to 1,000,000 gallons, and I come up with 0.005078 million gallons. So basically what I did is I took my volume in gallons, divided it by 1,000,000, and tacked on the units of million gallons. So this is the number that gets plugged in right here. Okay, so now I don't need to do step 3. I can move to step 4 and plug in my numbers and do the math. So my pounds of 65% HTH will equal 0.005078 million gallons times the dose of 100, which they gave us, times 8.34, divided by the concentration as a decimal, 0.65. Okay, so carefully enter these into your calculator. 0.005078 times 100 times 8.34 divided by 0.65, then hit equals. And I would do this 2 or 3 times to make sure you get the same answer. And hopefully you come up with 6.5 pounds.
If you need additional help preparing for a state license exam, click the link below and we'll get you some more information about our license-specific exam prep courses.